again, suppose the electron nucleus is what? It is of positive polarity. Okay, it is in positive polarity. We have a positive charge inside, and then there is an electron which is revolving in the orbitals. Okay,
Okay.
okay, revolving. So when it revolves in the orbitals, okay, it revolves. So there is, since it has a minus charge, okay, which kind of charge? It has a minus charge and it has a positive charge. So they feel what kind of force? They feel electric force. It is called electric force, and it is represented by F. Okay, Fe or F. Okay, anything you could try. Okay, so when you have like charges, plus and plus, or minus and minus, like charges. Okay, like charges. Then this is what? This is repulsion. Okay, but here,
Okay.
as you can see that there are opposite charges, plus and minus. Okay, then what kind of? This is attraction. Okay, attraction,
Okay.
and this is
Yeah.
opposite charge. Opposite charges. Okay, getting my point?
Yeah. I got it.
Okay, so when initially it was doing a study. Okay, the scientists were doing the study and they found that these kind of things. Okay, if the charges are opposite, there is attraction, and if charges are like, okay, then there is a repulsion. So they were very 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 keen to observe the force of the like how the force will be. Okay, the nature of the force. Okay, so there were two kinds of forces, repulsion and attraction, but now they were want to form the formula. Okay, so they found that there are they straight away they couldn't find the formula. Okay, what they have observed some things. Okay, so the property, first thing they have observed in the experiments, that this force between these charges, okay, what, it is proportional to the charges. Okay, it is
Okay.
proportional to the charges. Okay, suppose you have charge 1, okay, and then you have a charge 2. Okay, so it was
Okay.
proportional to the charges. If you are, suppose if you are increasing the amount, okay, if q1 is e plus e and q2 is minus e, then suppose the force is less. Okay, but as you increase the value of from plus e plus 1e to 2e, as you increase the amount of the charges, the force was increasing in that proportion as well. Okay, so they
Okay.
found that it was proportional to the what, q1 and q2, the charges. Okay, I should write force was force was proportional to the charges. Okay, okay, that was the first thing they have observed. The second thing they have observed, that force is inversely proportional to the distance r square. Okay, the force inversely proportional means, as you increase the distance, as you increase the r, the f will be what, decrease, right?
Yeah. Okay.
Okay, so it was inversely proportional to the distance. And what is the distance, like what kind of distance is this? R is basically the distance between the charges. Okay, that was the R. Okay, it could be same charge or opposite charge. So R is what? R is the distance between the charges. Okay, so force was proportional to the distance. Okay, distance between Q or charges. Okay, we should write charges. It is between charges. So that means if I increase this distance, suppose if I increase this distance, okay, if R is increasing between these charges, F is going to what? Decrease, right?
Okay.
As I increase the distance R, F is what? F is going to decrease. If I decrease the distance, F is going to increase. And what was the amount of increasing? That was R square. Okay, so it means as I increase the distance, F was you know, F was twice the amount of, or you could say squared the amount. Okay, the force was decreasing. Okay, and as I decrease the distance, it was enormously increasing the value of force. Okay, so this was observed, so that's why they have concluded that it is proportional to the R square. So can I write from the first two findings, can I write this? F is
Yeah.
proportional to Q1 Q2 and over R square. Can I write that?
Yeah.
Okay, can I write that? Now it's proportional. So what they have done, they have made a formula that is K. It's a constant Q1. Okay, when we remove the proportionality, it's K there, right? Q1 Q2 by R square. Okay, can I write that? K is what? Proportionality constant.
Okay.
Proportionality constant. Okay, that is called K. Okay, so what is the formula? Formula is F is equal to K Q1 Q2 by R square. What is Q1 Q2?
That's
Q1
charge.
Q1 is charge on first particle. Okay, and Q2 is charge on second particle. Okay, or entity, you could say entity, it could be
Okay.
anything. Okay, and R is what? R is distance between two charges. Okay, and what is that distance? You cannot take any kind of distance. No, you cannot take this distance is not taken. No, not like this. Any perpendicular distance, just remember that. Perpendicular distance. Okay, perpendicular distance. Okay, or you could say the shortest distance, or you could say shortest distance between two charges, that is R. Okay, so this is the way you could say F is equal to Q1 Q2 over R square, and that is K. K has some value. K is also called 1 over 4 pi epsilon naught. Okay, and these variables I will discuss later. Okay, this is called 4 pi epsilon 0. So okay, you can write the force as F is equal to Q1 Q2 over 4 pi epsilon naught R square. Okay, this is what? This is called Coulomb's law. Okay, this force is called, this interaction, this is called Coulomb's interaction or Coulomb's law. Okay, this force
Okay.
is
Yeah.
basically called what? Coulomb's law. Okay,
Yeah. Okay.
okay, getting my